research should be defined as doing something where half of the people think it's impossible. Impossible. And half of them think, maybe that'll work, right? When there's ever a breakthrough, a true breakthrough, you can go back and find a time period when the consensus was, well, that's nonsense. So what that means is that a true creative researcher has to have confidence in nonsense.
Channel. Entertain your brain.
257. Ready? 3, 2, 1. Lander release. One away. That feels good. Arm switch is coming.
Let me fly in space.
Let me fly in space.
Let me see that black sky.
Good, all set. Copy that. Firing switch coming. Mark.
On June 21st, 2004,
10 seconds.
a privately made rocket plane launched into history.
Left tunnel.
Its mission?
Whoa.
To become the world's first commercial manned space vehicle.
This is not good.
If successful,
Very rough ride initially.
the flight of Spaceship One will open a new era of space exploration.
Wow, you would not believe the view.
Moving forward to see that black sky.
In the middle of the Mojave Desert, the visionary airplane designer Burt Rutan and his company Scaled Composites, a renegade band of test pilots, engineers, and mechanics, are challenging 50 years of thinking about space travel.
Boomerang 24 Bravo Tango is taking the active 30. I'll be departing.
10 months ago, construction began on the first of two unique flying machines. Today, the team reaches a major milestone in their secret program codenamed Tier 1. Test pilot Doug Shane and co-pilot Pete Seabold prepare their mothership for its maiden flight.
John Scott 1-1, taxi 1 White Knight with 1 mobile on 30 for departure. What type is it? We're calling it a White Knight. I just gotta ask a question when I see something the same as usual. What is usual, John?
White Knight has just one purpose: to lift a rocket plane to 50,000 feet and drop it.
110, 120, watch the speed. Watch the speed.
Big vibration. Doug, your spoilers are flapping. Damn, the spoilers are sucking up. Had a lot of vibration.
Let's slow it down.
Mike, can you give me a look? Stand by. Okay, copy that. Spoilers are small flaps. Affirmative, about 3 or 4 hertz in there. It looks like they're going pretty big deflections.
It's a fulfillment of a dream, a specific dream that's about 7 years old.
Okay, Mike, everything seems fine below 100. We're trying to stay.
We are doing as a project here at scale right now, and we have been since April, a space program. Back in 1994, I started toying with what it would take for us to build a supersonic, even hypersonic airplane.
316.
The dream of this was such a phenomenally exciting ride. We're going to rocket and accelerate really fast. I mean, we're going to go 3.5 Gs straight up. That's a neat ride.
RCS on.
And then we're going to spend about 4 minutes weightless.
Please shut down. Here comes Stella.
And we're going to break out of the atmosphere into the black sky, and we're going to get the same view you do from orbit. Obviously, the world's greatest roller coaster would be a suborbital space flight that could be offered to the public.
Burt Rutan is not alone in his dream. In 1996, a group of space enthusiasts announced the X Prize, an international contest intended to jumpstart space tourism. The first non-governmental group to make a suborbital flight to an altitude of 328,000 feet, or 62 miles, twice within 2 weeks will take home the $10 million purse. Aviation prizes have a long history of inspiring innovation, including the $25,000 Orteig Prize that Charles Lindbergh claimed by flying nonstop across the Atlantic in 1927. Its modern-day equivalent, the X Prize, has 20 teams from 7 countries signed up to compete, including Burt Rutan.
Boy, did it straighten back out quickly. Pretty stable, huh?
In the late 90s, Rutan took his ideas off the drawing board for their first test flights.
A feather angle of 55 degrees. 50 degrees. Did I say 50? 50 degrees.
Research should be defined as doing something where half of the people think it's impossible. Impossible. And half of them think, maybe that'll work, right? When there's ever a breakthrough, a true breakthrough, you can go back and find a time period when the consensus was, well, that's nonsense. So what that means is that a true creative researcher has to have confidence in nonsense.
Over the last 3 decades, Burt Rutan designed, built, and tested more than 1 original aircraft a year.
About 100 feet.
In 1986, his Voyager airplane became the first and only craft to circle the globe without refueling. From his early home-built kit planes to his recent high-altitude research craft, his theories and designs changed the shape of things that fly in the air. Now, his sights are set a little higher. Construction of the dream begins officially in March of 2001, when investor Paul Allen pledges financial support for the secret project.
I think we're not that far from the time when private individuals with a sense of adventure can try some kind of space tourism experience. I think that kind of experience, to have that open up to be available by anyone, that's a very exciting prospect.
We have a counter to advance. Roger, thank you. What's the event register reading?
There's less than 500 people that have flown in space in 40 years. A lot of people want to fly in space.
And liftoff of Space Shuttle Columbia.
And they think that our government is working to make it, hopefully in their lifetimes, cheap enough for them to fly in space, when indeed they're not. Unless guys like me go out and do this, it will not get done, period.
Burt's plan calls for the team at scale to build 2 revolutionary vehicles. The first, Rutan's 316th design, is the rocket-powered Spaceship One. This 6,000-pound craft with a 16-foot wingspan seats a pilot and 2 passengers. The second vehicle, the mothership White Knight, will carry Spaceship One up to an altitude of 50,000 feet and drop it. The rocket plane fires its motor and climbs straight up out of the sky. Its rocket shuts down as the craft leaves the atmosphere. Without the velocity necessary to carry it into orbit, Spaceship One coasts up past the boundary of space at 328,000 feet before falling back to Earth. Its suborbital flight ends as it returns to land at Mojave Airport.
Okay, cut hard to your right.
6 months after Rutan and Allen forged their space partnership, Tier 1 planes begin to take shape.
Visualize two switches here. I want them in this axis. You don't want to be out in space with your arm pushing on a toggle switch when you have vibration and 3Gs forward.
A group of engineers, project managers, and test pilots gather to discuss the cockpit design to be used for both Spaceship One and the mothership, White Knight.
The thing I want to get from you guys is, do you like the basic orientation?
We're doing this on our own. We're doing this without the support of big governments. We're doing this low-cost way.
We also need a handle there and one back there. You know, for now, somebody ought to just go to the junkyard. You'll find all kinds of wrecked vans there, and just take some wrenches and go get you a bunch of those handles, because there's some real nice ones automotive guys use. Corey, why don't you get in there so he gets...
I was responsible for everything that went inside the cabin. Floors, the seats, the systems, the windows.
They're out.
Huh? Look at this.
These are my legs. These are Burt's legs.
In a cordoned-off area of the scaled hangar, White Knight begins to take shape in secret.
After I had developed the Spaceship One design and had a pretty good idea of what its weight and size was, I realized pretty early in the design process we're going to have to take some risks here.
One of Burt's biggest goals was to build this mothership as inexpensive and quickly as possible. We went out and bought a couple J-85s for not a lot of money. The airplane was then designed around these engines.
I took the risk that no one had flown this type of configuration, i.e. two booms with two separate tails and long nose gears on the booms. That's all a new configuration.
9 months after the start of construction on the Tier 1 program, Rutan's 318th design, White Knight, emerges from secrecy. Lead test pilot Doug Shane runs its first trial, a brake test.
Line up the door handle.
Crew Chief Steve Losey oversees maintenance of the craft.
Okay, we're going to go ahead and test the brake function. So we're going to move forward about 10 feet. Doug's going to stop the airplane, and then we'll push right back. Okay, here we go.
No brakes. Just keep pushing it as hard as they can and then stop them.
The brakes don't work.
What?
Check this out. When I push hard on the brake pedals, it opens the cabin door.
Moves the handle. Oh boy, that's a pretty good force, too. Careful.
Let's get a foam block or something to put between the teeth. There's no way we should operate this way.
Come on.
No, you can't get out. When you're building an airplane in a room by putting little parts together, you don't have an ability to get back away from it and kind of see the whole picture. As we were rolling it outside, I guess what I was thinking is, what is everybody else thinking? They don't think about risks. Everybody thinks all the airplanes are going to fly fine. There's no responsibility for them to have made a mistake. And it struck me, probably more than any other airplane that I've done, as, wow, this is really out there, kind of.
It's different in different light.
For some reason, I looked at it and I said, we are absolutely crazy, aren't we? Like, what I really meant was, we're really crazy to be taking this kind of a risk.
Okay, Pedro, here comes the power.
After minor modifications, White Knight sails through its test phase. Its successful first flights moved Rutan and the Tier 1 program closer to realizing the impossible and putting a man in space. In the birthplace of the sonic boom, the X-15, and the space shuttle, the mantle of innovation now rests on the shoulders of Burt Rutan.
That's right. Oh, that's a good lizard. Yeah, that's a good lizard. Okay. How about me doing a lion? Okay, I'll do a lion.
Like Chuck Yeager and others before him, Burt Rutan came to fly airplanes.
I started my career in the mid-60s college doing flight tests for Air Force airplanes. I found, even though I had a very exciting job, that I had even more fun at home developing my own airplane.
In a career that spans over 30 years and nearly 40 original airplanes, Rutan now faces his biggest challenge, manned spaceflight. The only previous winged vehicles to go to space, the X-15 and the space shuttle, experience extreme forces returning to the atmosphere. They could not survive re-entry without complex flight control and heat protection systems. Even with these elaborate measures, both the X-15 and the space shuttle experienced catastrophic failure upon re-entry.
4 or 5 years ago, as I was developing the concepts for our spaceship, I had ruled out having a winged re-entry vehicle. You have to very carefully control it or you're dead.
Rutan's strategy is ingenious. He folds the plane in half. According to his calculations, in its feathered configuration, Spaceship One naturally turns the bulk of its lightweight body into the airstream. It free falls stably and with maximum drag. And astonishingly, it slows the craft so rapidly that heat is not a factor. Spaceship One then reconfigures as a glider and returns to land at Mojave Airport.
That was probably the most wonderful part about the whole design process. When I got those first results back that showed that I have high drag and high angle of attack trim, high stability, supersonically, I had it.
Rutan may have the way to get back from space, but he also needs a rocket that can get them there in the first place.
Why don't we just go through the line here, 1, 2, 3, 3, 2, 1.
Rutan enlists 2 small hybrid rocket motor designers, EAC in Miami, Florida, and Space Dev of Poway, California, and sets up to see who can develop the stronger rocket.
I got this message on my voicemail in my phone. Oh, hi, Kevin. This is Burt Rutan. The Burt Rutan? Yep, the Burt Rutan. He didn't really say that, but it was like, wow, well, I've got this project. Give me a call back. I'm more interested in talking to you. Click. It was unbelievable. It was like Thomas Edison calls you on the phone. Says, hi, this is Thomas Edison. I want you to come by my place and we'll work on a project together.
Rutan's priorities are that the rocket be safe and cheap. Hybrid rocket motors fueled by laughing gas and tire rubber fit the bill. Space Dev is first to test fire their motor with a 15-second burn.
Okay, James, up in the cab, stand by to turn on the red light and activate.
I was a little bit nervous because the rocket motors that we had built and test fired here were 15 pounds of thrust. Burt's motor needed to be scaled up at 15,000 pounds of thrust. I think he was a little bit worried that he had picked a company that didn't have as much experience as he had hoped.
Right on schedule.
T-minus 10. Controller's handing it off to the conductor. Harvey, you got it. 5, 4, 3, 2, 1.
Rutan's hybrid rocket motor holds laughing gas, or nitrous oxide, in liquid form in a 6-foot diameter tank under extreme pressure. When the liquid is released into a 20-inch casing containing solid rubber and ignited, the compounds explode, thrusting hot gases out of the nozzle.
Okay, they should be purging.
They should hose it down.
It's burning in front now.
Oh, come on, guys, get it out. Is anybody talking to them? They need to get the water on the flange.
Well, we didn't intend to relight this motor anyway.
That's not the problem. Our tank is gone.
Rutan pioneered the use of composites in aircraft with his home-built kit planes in the 1970s.
Come up with a structure
that is very stiff and take extreme overload. Extreme overload.
The main reason I got into composites is I found that we could build airplanes more quickly, very much the way you make a fiberglass boat or a surfboard.
Rutan is using this same technology in Spaceship One. Matt Steinmetz, Spaceship One's project engineer, oversees assembly of the craft.
You know, this thing is not really different from a kit plane. A lot of the processes and stuff is real basic. It's not like a NASA space shuttle.
Sections of the ship are fabricated from multiple layers of woven graphite and epoxy resin. These join together to form the airframe of Spaceship One. Just fabric and glue.
Most companies would say, hey, you're just a kid out of college. You're not of a sufficient level to be in charge of a spaceship. Here they go. We're going to give you a lot of responsibility, and we'll see how you do it.
The resulting hand-built craft must fly nearly 4 times the speed of sound and sustain forces in excess of 5 gravities, or Gs.
Do you like that?
After 9 months of construction, Burt Rutan and the Scaled team revealed their secret space program to the world.
For the record, I'd like you to meet the person that put all this embroidery together, my wife. I'd like to introduce you to Spaceship One. This is the first private manned spacecraft. Everything you'll see is designed to put humans in space.
The manned captive carry flight of Spaceship One is a full rehearsal for its first solo test flight.
You know, we set out back 6-7 years ago to try and get people to think about a different type of capability. The technology isn't the issue, it's the way people think about space, and that's really the goal.
Hardest part's getting off the ground sometimes. How's the ride, Mike? Lovely.
As Rutan moves closer to his dream of barnstorming space, his greatest challenges still lie ahead.
Couldn't be better. Rock solid. Okay, go on.
After the success of Spaceship One's manned captive carry flight, Burt Rutan turns his attention to the hybrid rocket it needs to get to space. 2 months after SpaceDev's first test fire, the second company in Rutan's rocket competition, EAC, fires their hybrid motor.
This particular motor, compared to SpaceDev's, the components have had a lot more actual live fire testing, so it should be a lower risk than the other one. But we'll see.
Is there any key to opening these things?
In addition to measuring thrust, today's test evaluates the heat emitted by the rocket motor.
You got a steak? Gotta have buns.
This time we're getting some representative samples to look at radiant heating from the plume, too. So we have aircraft structure down there, as well as some T-shirts and a little bit of campfire food.
Perfect.
NASA has never generated that data. As we understand, we've done an internet search, and there's absolutely no data on what it takes to cook a hot dog next to a rocket plume. And so we're going to find out today.
Are we going to be able to eat these marshmallows afterwards?
Yeah. Now, at 7.5 seconds, everybody's got to rush in and turn the weenies around.
Yeah.
Plus 10. Plus 15. Hi, Mom. We're going to space with the Birdman.
Made a good show over there?
Okay, outstanding. Can we go look at the food?
Yay! Beautiful.
The resounding success is countered by tragedy. During the first flight of his home-built plane, Scaled's propulsion coordinator, Dave Thompson, crashes and dies. It is a brutal reminder of the dangers of flying. The night before Spaceship One's first solo flight, Burt Rutan and the Scaled Composites team gather around their creation.
This is static pressure right here.
Aerodynamicist Jim Ty shares some of his most recent predictions for tomorrow's flight.
My job is determining how the airplane's going to fly, how high it's going to go, how fast it's going to go, what sort of forces are going to be imparted upon the airplane.
Elevator speed, staff. So if you have 1 degree nose up, staff.
and 10 degrees nose down, that's 10 divided by 2 is 5, minus 1 is 4. So it's effectively 4 degrees of stab nose down before he launched.
I'm not going to move the stick at all for the first 3 or 4 seconds.
Mike Melville will pilot the first flight of Spaceship One. He constructed the first plane built from one of Burt's kits while still a machinist in Indiana. He and his wife, Sally, flew to Mojave to show it to Burt and became Rutan's first full-time employees.
It's very stressful to be married to a test pilot.
Did you hear that thing ring throughout the building? Wow.
What I personally do, the way I cope with it is I have to build up a wall. I build up a wall.
How the heck you get in here?
Tomorrow, Mike will drop from 47,000 feet in a plane that has never been flown. No one knows for sure if it will even fly.
We don't know, the spaceship has not been in a wind tunnel. If this was Boeing or somebody like that, by the time they would fly it, which would be years from now, they would know exactly how it would fly.
That'll work. Practice all you want there. Doesn't do anything.
Okay, what about the nose thing to try to... The handle is right here, right? I personally put a lot of faith in Burt's ability to predict how it's going to work. Prior to flying, we'll always sit down, he and I, and he'll tell me how he thinks it's going to fly, and he's never been wrong.
Jim Tighe's computer analysis predicts that Spaceship One will fly perfectly tomorrow. Just in case, they review the bailout procedure.
What you want to do is duck your head and throw your body out. Yeah. If you're in a spin, it's going to throw you out as soon as you let go of the belt.
So you'd go out like that?
Well, no, just put out. Yeah, exactly.
So you'd
just go out.
Like that.
This morning, Digme Scaled Composites faces what may be the most dangerous first flight in the company's history.
Okay, good morning. It's 7:24-ish. 5:24-ish. What day is it? 7:24 in Wichita. We're here for the Spaceship One first flight. Weather has improved over the forecast. Satellite photo shows all the stuff hanging over the field is moved out to the east.
I've had any number of people, guys as well as women, come to me and say, well, how can you let him do that? I don't believe I have the right to tell him what he can and can't do, even if I think it is high risk and life-threatening and whatever. I mean, this is his ultimate joy.
Sally worries a lot, my wife, and she seems to worry a lot more now as we both have got older. And recently we had an accident with one of our guys last week, and that's really brought it home to, we never dreamed we'd lose that guy.
Horseshoe Michael gave me when I was 17 years old. He had it made, and it has our names and the date when we met. And it's always just been something special between us.
It's my good luck charm.
Okay, I'm ready to go. Attention all aircraft. Weather, we got calm winds. Altimeter is 3004. Temperature is 71 miles per hour.
Looking for takeoff clearance?
I think this is the most hazardous flight we've ever tried to do.
1-2 for White Knight. We're set upstairs. Roger, copy. Mojave traffic, White Knight's on the roll.
We've never ever taken an airplane and dropped it from up in the sky, having not done any flying on it at all.
Off we go into the wild blue yonder, huh? Here we are.
White Knight ascends to 47,000 feet, 10,000 higher than a jetliner, before releasing Spaceship One.
102, 40,800.
You all set back there, Corey?
Yeah, I'm all set.
Okay.
Thumbs status? Thumbs go for launch. 16. B-16 is on. Stand by for countdown. On my mark, 3, 2, 1, mark. It's away. It's a clean break. Feels like a clean break. Vibration.
Can you see anything, Brian? Oh, they're there.
Hey, the airplane flies pretty nice. Okay, trimming now to 0, stick force, takes quite a bit of nose up trim. Flies like a dream.
Damn, that's a good airplane.
Yeah, the release was definitely 0G. I was surprised. I had some things float up and hit the roof. 1-2 from scum, we show you green for landing. Copy that, gear to go. Gear's coming.
Gear's coming.
There's the gear. I heard them all. Looks like 3 green from here. Touches.
Chase planes give Mike eyes outside the ship to help him land safely.
3, 1.
That was so sweet.
I love you so much. I love you too. You did a beautiful job.
A little for Burt. Water on me. I want to congratulate the entire Scale team in bringing this very important project to the state that it's in right now. And with that, we're moving forward to see that black sky.
Spaceship One's triumphant first glide marks a major milestone for Rutan and the race for space. With Dave Thompson gone, Brian Binney and John Campbell oversee the propulsion program.
So here we have Space Dev coming in first. The test itself went well, and we finally went to shut the motor down. Wouldn't shut down. We had a fire. We couldn't get it to go out. And it was horrible. Contrast that with EAC's first firing. It fired, it ran, it shut down, it was smooth, it was a good, solid rocket motor, and the contrast was enormous.
Do it again.
They were very different in the way they approach things. The Space Dev crew come from a more big company aerospace background, more interested in the documentation and taking logical steps.
And then what followed was quite interesting because the next 4 times out to bat, EAC couldn't get the motor to light.
Okay, somebody support this at the back.
The tables now were really tilted in the opposite. EAC, which had enjoyed the misfortunes of Space Dev getting off to a bad start, was now really having to scramble to play catch-up.
The final tests of the 2 rocket companies bring the competition to a close. Rutan sets up conference calls to announce his decision.
Hello?
Oh, hey.
Who am I talking to?
Everybody you know in Miami.
Do we have the Space Dev rocket development team there?
You've got us hanging by a thread, Burt.
Because both teams were so closely matched and since both have developed satisfactory motors, the process to select one of these vendors to enter the motor qualification and flight test phase was difficult. However, today, Scale is pleased to announce that it has awarded the contract for propulsion support for Spaceship One flight test phase to Space Dev San Diego. Onward and upward. Looking up, way up.
Comprehensive testing of Spaceship One continues with a series of glide flights. Each mission expands the envelope of the plane's known capabilities.
Airplanes go so high and they go so fast and they go so slow. And every time you go higher or faster, you're doing something new. So that's envelope expansion. There's always the possibility that something's going to happen unexpected.
A heavy beast, huh?
These envelope expansion flights will allow the 3 test pilots, Mike Melville, Pete Siebold, and Brian Binney, to explore this unique aircraft's ability to fly.
Okay, release on my count. 3, 2, 1. And good release. Clean release. Good release. It's about -1, a little bit of dust over the top. Left rudder.
Pete deploys the feather.
Feather is coming.
As Spaceship One folds in half, a camera mounted in the right tail looks forward at the body of the plane.
Get close both the arm and fire switches. See if the MCS is done.
The feather performs flawlessly, allowing the plane to drop through the air just as Rutan imagined. The Scaled Composites Unit Mobile, affectionately dubbed Scum Truck, serves as mission control for the flights. From here, aerodynamicist Jim Ty monitors the status of the plane.
My primary responsibility during this flight test portion of the program is to check data that we get from flight tests, compare it to what my predictions were, and then see how they differ.
Today, Mike Melville tests the predicted speed of a stall.
A stall is when the air flowing over the wing no longer stays attached to the surface. It's not developing any lift anymore. And as soon as it stalls, you're not an airplane anymore, you're just a 2,000-pound lump falling out of the sky.
Carrying sandbags to simulate the weight of rocket fuel, Mike Melville slows the plane.
Okay, buffeting in the tail already. At night, there's a big pitch up. Big pitch up.
He finds the tail of the plane suddenly dropping.
Using nose trimmed out.
Spaceship One has stopped flying.
Okay, it departed at about 85 maybe.
To keep it from falling backwards, Mike rolls Spaceship One over.
Understand you under control. Negative. Say again. The part of the plane is not under control.
Jim Ty sees what has Mike trapped in a spin. He tells Doug, who relays it to Mike.
Way out of trim, Mike. You need to come back on the roll trim. 33,000 pounds under control. Wow. That was exciting. Are you under control? Hey, farm, we're under control. Gotcha.
That's why we do flight tests, because when you design something as radical as the stuff Burt designed, it's not going to be straightforward. But it's disappointing because it's somewhat of a setback. We've got an aerodynamic problem, and we got to fix that.
I made a decision that would be made by any airplane designer, is that you really need some wind tunnel data, and I needed wind tunnel data right now.
They can spend millions and months at a massive wind tunnel facility.
We slam some stuff together, break out our super glue, and go to town.
Or they can use the Land Shark, mounting a full-scale model of the tail of Spaceship One in front of a pickup truck. Jim Ty analyzes 25 different tail configurations in less than 2 weeks.
Stabilizer at 0, 0 elevon, 55 knots.
My very first airplane, the very big one, was developed on a wind tunnel mount up above a 1967 Dodge Dart station wagon.
Landshark data reveals that the tail is too small for stable subsonic flight.
We needed more tail area. As you can see here, we've actually added 16 inches on the elevator, the movable part of the control surface, and 16 inches on the fixed part of the tail. But he's nailed it. It's perfect.
Spaceship One's next challenge will take it faster than the speed of sound. With a live motor bolted in place, the Scaled Composites team readies Spaceship One for its next big hurdle, rocket-powered flight. If all goes according to plan, this will be the first Rutan craft to go faster than the speed of sound.
It's definitely the riskiest venture that we've taken part in by far. We're trying to develop a man-rated rocket. We're going supersonic. It's a lot of new territory that we've never been involved in.
The first powered flight of Spaceship One will burn its hybrid rocket motor for 15 short seconds, thrusting pilot Brian Binney straight up and across the sound barrier.
Good morning. The lens look pretty nice. Mission control.
Airplane's ready to go.
Let's get out. We really need to be on our toes and alert. You got to be able to light that rocket motor and turn that corner and get through transonics and get supersonic and stay far enough ahead of the airplane that you can manage all the other devils that lurk in those regions.
Big deal last time was trying to keep the toes warm, so I got some extra socks. And there's no heater, and you're about 3 plies away from minus 60, minus 70 degrees Fahrenheit at altitude, so your toes are right at the pointy end of the vehicle, and
not get much warmth.
I need all the required equipment.
What's really going to get you is the thrust. There's almost 2 G's worth of accelerating just due to the thrust alone, plus gravity because you're going straight up.
All right, Brian. See you when you get back.
One thing here. Lucky charm.
I gave him a medal, Our Lady of Loretto. It's supposed to protect all aviators, flyers.
What's that?
I trust his experience. You know, he knows what he's doing. And I'm sure Burt and the crew wouldn't allow them up there if they didn't believe in it, too. So I have to believe in that.
How far does it actually drop before the rocket ignites?
As soon as it lets go, we're going to light the rocket motor within about 10 or 12 seconds. On this rocket flight today, we expect this smooth buildup in thrust. However, when we shut the motor off, he'll instantaneously snap his head forward to a G forward. Today, we're going to go to about 900 miles an hour.
All right, Mike, see you at 15.
Thank you. Yeah.
Tower, White Knight flight is holding short at 30, ready for departure. Runway 30, clear for takeoff. Roger, White Knight. White Knight's rolling.
Okay, gear up.
It's coming. Still mobile ground. Launch. Scum status. Let's go for release. 316 status. Go for release. 40 seconds. 10 seconds. 5 seconds. 4, 3, 2, 1. Mark.
Good.
Bridge release. Looking good. Scum status for ignition. Let's go for ignition. Go for ignition. Arm switch on. Green light. Stand by for fire switch on my mark. 3, 2, 1. Mark. There we go. Good light. 10 seconds. 15. Beautiful. Okay, ignition's on.
The motor burns out. You're riding the bull, so to speak, slowing back down from supersonic to subsonic, which tends to rock the wings, and you're trying to get the feather out. And the feather is like the saving grace. It's the angel's wings in this vehicle. If you can get to the feather and get it out, you can get it home.
Feather unlock. Clear feather. How you doing, Brian? That's a pretty wild ride, Mr. Rutan. Roger that. Now stabilize the feather. Copy. A lot of side-to-side rolling here. He is descending through 55,000 feet now by my call. We have you inside, you look good. Just start defeathering, we'll get you going on that. Okay, here comes feather coming down.
When you come through on the other side and the shocks are all established, you're back to a pretty stable airplane that flies just fine.
Oh, man. Hey, clear to land.
There is some risk, and you got to be alert enough to recognize danger before it gets out of hand. And you hiccup in one spot, you potentially can have a bad day.
20, 10, 5, 2. Fire truck.
After the triumph of Spaceship One's first rocket-powered boost,
Hey, clear to land.
pilot Brian Binney comes back down to Earth.
5, 2. Fire truck, fire truck.
He's upright, but he's off the runway.
Flew into the ground much faster than what the landing gear is designed to arrest. One landing gear failed, the other miraculously stayed intact. It's not Brian's fault, it's just that the flight controls weren't working as intended and bind up, and you have to kind of wiggle the stick and get them loose. Brian would have had to apply about 12 pounds of force on the stick to break it free, which isn't something you want to do when you're trying to do fine maneuvering.
Hey, other than that, how was the flight? Words cannot describe how disappointed. You did a super job. All we've got there is real minor stuff. It's not a big deal.
It'll be flying in a month.
No, really,
It will. It will.
This is all real minor stuff. How was the boost? Pretty wild. The kick and trying to keep the wings level, all of that was real dynamic. Just when you think you're kind of under control, something different would happen. This is the first time that a small company, without being supported by the government, has developed and flown a supersonic airplane. Now, you would think that the first private sonic airplane would just barely go supersonic in level flight. This morning, we went supersonic climbing almost straight up. That was cool.
All in all, the test was a major success, you know, up until the landing.
We got through the sound barrier without any problems, and we went to maximum Q. We've seen how our ship flies supersonic. Technically, it's enormous.
Spaceship One's cable and pushrod flight controls bind up and become useless as it passes through the sound barrier. Supersonic speeds require an entire tail stabilizer to pivot or trim to control the plane.
Beautiful. Okay, ignition's on.
The F-16 and the space shuttle, the pilot couldn't fly it without a computer sensing what's happening and helping the pilot fly it. I didn't have that option because I didn't want to add the enormous costs of the computers.
In 1911, Chuck Yeager proved that a human being could fly faster than the speed of sound in the early X-planes.
That was the last time anyone went supersonic in a mechanically controlled airplane. All of the stability augmentation comes from the seat of the pants. Quick thinking, and if you made a bad judgment, you're going to bite the dust.
Rutan's space program replaces the computer controls with the TNU, or Tier 1 Navigational Unit. This single display provides all the information the pilots need to fly their craft.
Arm switches on.
Both the TNU and the flight simulator the pilots used to train were designed by Pete Sebold.
Really? Arm. Fire.
You've got an airspeed indicator, an altimeter, and it tells you whether you're upside down, right side up, backwards, forwards, tells you where you are over the ground. But we really tried to simplify it and make it work for this mission.
After 3 years developing this crucial portion of the program, Pete gets his chance to fly the rocket.
Roger, this is Flight 3 Lima 13P. It's 8 April 2004. Pilot Binney, co-pilot Steinmetz, Sebold in the spaceship, and off we go. And the heavy traffic, white nights on the roll.
I'm an engineer, and I'm a pilot. Those two traits tend to conflict sometimes. I love problem solving. On the other hand, I tend to be a little bit too analytical.
It's just something interesting. When I move the yellow bonds, I get trim indications. Well, that is interesting.
The second powered flight plans a 40-second rocket burn, taking Spaceship One higher and faster and testing the feather in supersonic re-entry.
And Spaceship One's looking for landing clearance. Heading over to right now. Have a good flight. Stand by. 3, 2, 1, release. White Knights, forward verify 6. Oh, big separation. Well, here I get main wing, lots of separation.
the airplane started acting as though the wing had stalled, and it was something we haven't been expecting.
I'm going a little farther forward, stab trim.
Why? That'll get faster.
We think you'll end up faster with that, Pete. Yeah, I know. I'm in a dilemma here.
My only option was coming back and landing heavier than we'd ever been before, or go fly this mission and possibly have really bad handling qualities.
There's really pretty lousy lateral directional control.
If he lights the rocket and loses control, Pete could end up too far away to glide home, or worse. But landing without burning off the solid rubber fuel is an even riskier option.
The airplane is going to be so tail heavy that you'll be landing with a stick all the way forward, and you'll be going 150 or 160 knots when you touch down. And if you don't make a smooth landing, it's all over.
I want to get rid of that. I agree.
Pete had a concern for the airplane's flying qualities just as it came off of the White Knight.
We should go.
We think you should go.
We felt it was a lot safer for him to fire the motor than to land with a full load of fuel.
Okay, arm switch coming. Better. 3, 2, 1, mark. 15 seconds. 30 seconds, 3-0. Shut down clean. 40 seconds.
Spaceship One's momentum carries Pete up to 105,000 feet.
All systems are green, Pete. How you doing? Great. The sky is dark.
High, but short of the goal for the flight.
All systems green, Pete. Good shape.
Someone asked Werner von Braun, who's my hero, my mentor.
Thunder coming.
Someone asked him, what's the most difficult thing about going to the moon?
Copy.
And he says, the will to do it. The engineering is just calculations, but the decision and the will and the courage to try to do it is the most difficult hurdle.
Apogee 105.
As Pete descends in feather, air approaching supersonic velocity flows over parts of the craft.
Picking up lots of rumbling here, 55 knots. Lots of side-to-side oscillations.
Pete dumps the remaining liquid nitrous oxide.
Copy, 0.83 Mach through 78,000.
Due to the ignition delay, spaceship reached the sound barrier on re-entry as they had hoped.
Suggest you start out of feather, Pete. Feather coming out.
We didn't go as high as we wanted to.
Slow and moving.
And we didn't get our supersonic re-entry, so we didn't reach all of our goals.
And airport's 11 o'clock now, 12 miles. Inside. Copy, how you doing? Good. Gear's coming.
He drops the recently repaired landing gear and makes his approach.
Looking good. 5, 2, 1 push. Perfect, Pete. Beautiful job.
Great job, everyone.
Super. We're thinking we did a super job, man. But when you said dilemma, this is a real dilemma to be landed with all that fuel.
That was the dilemma.
So glad.
Best landing, man.
I can't wait to see the footage.
That was a great landing.
Yeah. See it all the way to the top. The plume looked very straight.
Yeah, it did.
And it looks like you corrected past vertical to get back on.
The motor runs so smoothly.
Thank you.
It's not loud.
It's not loud.
I think it would.
You know, I thought, wow, that just felt like somebody tipped me on my back, and that was the real. A lot of things were exactly how I thought they would be. A lot of things were just no big deal whatsoever, and I made them a big deal early on.
Okay, debrief.
The hardest part was to take what we do in the sim, where we just sort of let it do its thing, to be in the real vehicle and just let it ride itself out. So.
With a harder road ahead than expected, Pete's piloting skills inspired the group.
But today, people are being scraped off the ceiling, I think, quite literally. Today's flight really does get our feet back on the ground running, and yeah, but we expect challenges because it's space flight.
After 7 glides and 2 rocket-powered flights, Spaceship One faces another hurdle.
During this year and a half or so of motor development, our spaceship got a little heavier.
The changes in the tail fixed the stall problem, but they added weight. Rutan begins to question whether he has the power necessary to reach the X Prize.
There's a lot of ways to get more altitude out of the spaceship, but the easiest one is just to take a pound out of the spaceship. If we can figure out how to make it a pound lighter, it goes another 150 feet or so higher.
Areas like this where there's a lot of beef because the spars there.
The job of taking weight out of the plane falls to engineer Matt Steinmetz.
They took out all the wiring that wasn't being used. That was 4.5 pounds right there. Wow. Yeah, that's what I said.
With the weight optimized, the pressure is back on the rocket. And Campbell.
Several months ago, we thought that the motor we had at that point was plenty to get to the X Prize goal. But since then, we've got a lot more data. And we said, you know what, we're not quite there. So we had to add a few more pounds of fuel. We're just pushing everything right to the limit.
Their data shows more thrust, but the unstable burn could make for a very wild ride for the pilot. Anticipating the multiple gravitational forces he'll face during tomorrow's flight, Mike squeezes in some last-minute physical training.
Here we go. I felt that I needed a little more unusual attitude recovery practice. I pulled it up as high as we'd go and just let it fall backwards, and then try to figure out where I was at and get it straight.
Left rudder, 4-6. 1, 2, recover. Good.
That is disorienting.
Yeah, it's kind of cool.
Also wanted to do some G tolerance buildup.
7.5. Good one.
I feel great. Ready to go.
The third powered flight of Spaceship One will burn the motor for 55 seconds, go higher than 40 miles, and most important, test the feather at supersonic speed.
It's an aggressive envelope expansion. It will be the first time we're supersonic with the feather up.
It's going to be the highest Mach number that the spaceship has been to on the way up and on the way down. It's going to definitely be the highest altitude.
They'll be going faster and higher and hotter than ever. Several pinstripes of temperature-sensitive wax will tell them how hot the lead surfaces of the plane become.
Ready, Steve?
A rifle bullet out of an M16 goes 2,700 feet per second.
There go the shots.
We're going to go 300-400 feet per second. That's 2/3 of a mile every second. And if you look at that vehicle, it doesn't look like it could go that fast. It's just made out of fabric with some epoxy glued to it to keep it stiff. It's got plastic windows, and it's going faster than a bullet. There's some risk involved there.
The last-minute rituals of flying fill the moments before departure. Some seem ordinary and unconscious, and some don't.
You've been married 43 years. That's a long time. I wouldn't trade anything I've done for anybody else's love.
See you soon.
As White Knight carries Spaceship One up to launch altitude, Mike prepares himself by visualizing the coming 55-second rocket burn.
White Knight, John.
You're really fighting for your life there, it seems like. At least in the sim, you're paying extremely close attention to the Tanu guidance system, which tells you which direction you're going. You've got to have your eye glued to the screen. You can't be looking out of the windows or anything. You have to keep that anticipation vector pointed straight out.
316 status. 316's go for release and ignition.
Long 70 or 80 flights in the simulator. Some of them killed me, others of them were successful.
10 seconds. Hey, good luck, Mike, on this. 257. Ready? Yep. 3, 2, 1.
Clean release.
Sim feels good. Arm switch is coming. Mark. Good light.
Moments after rocket ignition, the guidance display begins to flicker.
20 seconds. A little right now. Tanu's on the blink. 30 seconds. Little right roll trim. Last to Tanu. Wow.
With no Tanu to guide his flight, Mike Melville is faced with a hard choice.
40 seconds.
flying blind, or aborting the mission.
Oh, heading. Good on heading. Roll left.
Go, Michael, go.
Incredibly, he continues the burn.
50 seconds. 55. Shut. Okay, Canoe came back. Copy. Clean shutdown. Doing okay? Doing good. Copy that. We're 205,000 feet, still climbing.
205! Woo! Woo!
Very, very dark. Just north of the bullseye, 1 mile. Okay, feather is out. We're leveling. Copy. He's peak at about 212 and 2 miles north of the bullseye. Copy.
It looks like a big map down there. It looks like looking at a globe, all lit up by the sun.
We headed downhill. That's the first.
But because there's no atmosphere where you are, the lack of atmosphere that you're in is black. It's black as ink. And so that's a very strange thing to see for a normal person or a person who's never been in space.
Radar imaging from nearby Edwards Air Force Base captures Spaceship One's feathered shape as it reaches apogee and begins its descent. Now comes the big test. How will the ship hold up as it re-enters the atmosphere in feather at supersonic speed?
It's not possible to take a light airplane like this and go that high and come back without a feather. If we get up that high and can't put the feather up, we're dead. Things is going to burn up like the shuttle did. As soon as it gets in the atmosphere, the tails will turn the nose down, and the speed's just going to go to Mach 4 or whatever. Then it'll get too hot, then the epoxy will melt, the thing will just come apart.
Okay, Mach 1.3. Down. Some fairly low frequency, high amplitude swinging around a little. The ping pong ball's doing its job. Copy. Okay, we got 32 knots. We're starting to feel the cue. Okay. Okay, Mach 1.9. 2 Gs.
He dumps the remaining nitrous oxide.
Heavy pitching in pitch. Okay. Not much in roll yet. 3 Gs. 95,000.
The remaining dangerous unknown, when the plane slows through the transonic barrier into subsonic speed,
85,000.
passes without incident.
Pretty subsonic. It's just one out of trims. One out of trims to go. The typical vibration happening now.
The vibrations in the plane increase, but this is familiar territory. Ironically, the heavy vibrations come as a welcome relief.
Feather is locked. Everything's green here.
Looking out the windows. But that would be unbelievable.
You don't even need it today. You need the ping pong ball.
That was fabulous. Well, I would pay $1 million to do that again.
Canoe's on the blink.
Luckily, it didn't go out until I had it vertical.
Lost the canoe.
By putting my head real straight and staring straight ahead and looking out of the very corner of my eye, I could see the horizon, and I could see it was black in front. So I knew I'm going up.
Oh, heading. Good on heading. Roll left.
Because I wasn't staring at the canoe, I watched the blue sky just go completely black. Until it was just black. I thought, man, in the middle of the day, the sky goes black. You know, how weird is that?
Lost the canoe.
I'm looking at video of the motor running and you climbing out of the atmosphere, and I'm looking at good data, and you said I have no canoe, and everybody's expecting you to abort. And I says, he's going to run it at least 30 seconds. And then I said, no, he's going to run it at least 40 seconds. And I said, no, he's going to run it all the way.
Damn right.
The lessons from today's flight are what make the next flight possible.
The big thing that we learned today is that the ship does re-enter in a carefree mode very well. That was our biggest risk today because we had never been there before. We had only been in that feather mode subsonically.
Oh, it was great. Boy, when I put that feather up, I was so glad.
Apogee headed downhill.
Here I was spinning around and having a good time. The feather just straightens you right out, sets you down. You hit the atmosphere very softly like a cushion. It's like falling into a feather bed.
Next stop, space. After nearly 3 years of construction and testing, the Spaceship One program is nearing its goal. With tomorrow's flight, Paul Allen, Burt Rutan, and his team at Scaled Composites will attempt to achieve what only 3 of the most powerful governments in the world have done before them: to put a man in space.
Tomorrow, we will attempt to add a new page to the aviation history books. If our attempt is successful, Spaceship One's pilot will become the first civilian pilot to ever cross the boundary of space in a completely privately funded vehicle.
For tomorrow's flight, Brian Benny will fly the White Knight. Mike Melville will be at the controls of Spaceship One, and Pete Sabol backup.
Burt came into my office and put his hand out and said, "Congratulations." I didn't know what he was talking about, and I said, "Well, what's going on?" And he said, "He'll be flying the Spaceship One."
The envelope expansion for this flight is substantial. Spaceship One will go 3 times the speed of sound and twice as high as it's gone before, to an altitude of 62 miles. In order to reach that height, a new, wider nozzle is installed on the motor. Jim Ty came up with another idea to help the plane's aerodynamics.
This aft fairing is designed to reduce drag. Drag is the force that the air imparts on the vehicle that slows it down and keeps it from going high. And so by filling in this area with this fairing, the air slows the airplane down less and hopefully goes a little higher. This will be the first time we've flown it. But the computer says it doesn't change the way the airplane flies, it just reduces the drag. So hopefully the computer's right. Otherwise, I might be in a little bit of trouble.
The population of America's new inland spaceport more than doubles as a windy dusk envelops Mojave.
Clearly, there is an enormous pin-up hunger to fly in space and not just dream about it. We do want our children to go to the planets. We are willing to seek breakthroughs by taking risks. And if the business-as-usual space developers continue their decades-long pace, they will be gazing from the slow lane as we speed into the new space age.
On the eve of this historic first step, Burt's vision for the future seems closer than ever.
Just some stuff I've been working on. This is an orbital system. If it goes to Earth orbit, it's Tier 2. If it goes beyond Earth orbit, you know, L to L2 or the Moon or Mars or the stars, it's Tier 3. Anything we do with suborbital is Tier 1. This looks like a White Knight, but it's bigger, much bigger. 7-place spaceship. First of all, you spend a week in space. This spins. This is von Braun's 2/10 of a G. You can exercise by running around this thing. But you have a few hours yourself on your vacation to do a spiritual experience floating inside a dome and looking out. Let's talk just a minute about Pluto. There is a private mission to explore Pluto. Just a few days ago, the program manager of this came to me and he says, "Burt, we want to send to Pluto on the first private deep space mission." God, it's hard to say this. We want to send 100 grams of Spaceship One. Isn't that cool? These kinds of things have been happening a lot the last few days. And it's hard to work and it's hard to sleep.
A lot of proud people around here that wanted to sign with their name on it. Would you like to sign it?
Sure.
Steve, need the the gold marks, Mr. Allen can sign the nozzle. And I want your signature in the cockpit.
Great.
So when it's displayed at the Air and Space Museum, it's still there and visible.
I think every one of us wishes that we could be on that vehicle and fly this really challenging flight. This flight is what's going to get the attention of the world. This is the flight which says, hey, NASA, we're here.
T-minus 4 hours and counting. After years of dreaming, Burt Rutan and the team at Scaled Composites hope today's flight will a new age of space travel.
As we briefed yesterday, try to get to flight 15P off safely today, above 100 kilometers. Timeline, we're still trying to taxi at 6:30 out of here. Spaceship status?
We had a thermocouple issue that we fixed, and the ops check, it's good to go now.
Great, thank you. Propulsion, John?
We're good to go, no issues. So what do you think? Very good.
No nerves, right? Nerves of steel.
Yeah, me too.
A little bit.
I have to believe that Burt knows what he's doing, that Jim Tye knows what he's doing, that Matt Steinmetz knows what he's doing. Those guys are brilliant engineers, and they have assured me it'll handle the speed, it'll handle the G, it'll handle the re-entry temperatures. See, I'm not an engineer. I actually am a high school dropout, so I can't make those calculations.
For the biggest flight in his career, Mike draws his final inspiration from the man who hired him over 25 years ago.
All of my flying career with Burt Rutan, with 10 first flights with him in airplanes that have never flown before, I've always had to believe what Burt tells me. I have to believe him 100%, because if I have any doubts, I'm going to get out and walk away. And for me, Burt Rutan, I don't know what to say. That man is unbelievable. He really is. He's one of my best friends. He's never let me down, and I don't think I've ever let him down, and I don't intend to.
This is the big one, Burt. Cool. Thanks so much for the opportunity.
We got the right guy.
Yeah, I think so.
It's just an airplane. Don't worry about it. Looks pretty nice in here. It's not really an old airplane, is it?
Yeah, you should just hop in the back.
Should I do that right now?
Yeah, he's going to have to hold on tight. There's no seatbelts in there.
He's scared, and he admits it. Test pilots do that right up to the launch.
Yeah.
And then after that, there's no fear, because you have tasks to do.
Everything was just kind of going normal, and you're sitting there in front of the hangar, and yeah, there's 100 people around, but nothing different. And I thought, boy, this is the only people that showed up for this, is these few hundred people here. We kind of rounded the tower, turned in the corner onto whatever taxiway that is, and just the windows in the white night filled up full of people. And I thought, oh my God, there's thousands and thousands of people just filled up the windows on the airplane. So that was breathtaking.
Holy smoke! Holy smoke! Will you look at that? And it's only going to get bigger.
As Spaceship One and White Knight head toward the stars, 12,000 admirers draw forward in anticipation.
I feel like I'm at Kitty Hawk. It's like being at the Wright Brothers at a new stage.
Dreamers of all ages have their hopes riding skyward with Spaceship.
I'd like to go into space. I want to ride. I want to go now. I've been waiting for over 40 years for this. When we stopped going to the moon 30 years ago, I was disappointed and upset then. So I'm glad to see private enterprise getting into the game and doing it themselves.
Last chance. Anybody? Okay. Spaceship One is on.
The historic flight of Spaceship One begins.
Release. Armed and fire.
There it is. Oh, there it is. Yes, yes.
Go, Michael! Go, babe!
Good night. 10 seconds.
Suddenly, a problem. As Spaceship One rolls to the left, Mike tries a new method for correcting his course.
The wind shear and or me overcorrecting caused the airplane to roll 95 degrees to the right.
Left pedal. Left pedal, left pedal.
Trying to get level, he overcorrects.
So then it rolled 90 degrees left. And I very nearly shut it down, because, I mean, you feel like you're pointing back at the ground at that point.
Auto symmetry.
Way off course, Mike finally manages to get the ship under control and vertical.
Looking good. Okay, 30 seconds coming. Very rough ride initially. Copying. Little nose up trim. 45 seconds, slightly low on energy. Doing okay? Yeah, a lot of pitching.
Struggling to escape gravity's grasp, the rocket motor wails.
Slowing down on him. We're pretty course trajectory error here. You got to be careful. Okay. Engine shut down. I did not shut it down. It shut down on itself. Yeah, one full duration. Shutdown's clean. Okay, rates are really good. Copy, feather green.
As Spaceship One drifts further from Earth, Mike's isolation is aggravated by mysterious noises from the ship.
I had at least 3 different pieces go out the back that caused bangs, and one of them was very large, the other 2 were much smaller. I didn't know what that explosion was. It just was a mental strain on me, because I honestly thought that the spaceship had lost a major part of itself.
Feather coming. Copy, feather to be expected.
Unsure of the condition of his craft, Mike raises the feather and continues his ascent as planned.
Yeah, the engine didn't run very well. Doing okay, Mike? Doing fine, trying to get it up right. Wow, you would not believe the view. Holy mackerel. Doing a really good job with the RCS.
Approaching the top of his climb, Mike appears to be in perfect position.
Okay, everything is good here, Doug. Okay, copy that.
In fact, his wild ride left Mike over 20 miles off target, calling into question whether he made it into space to 328,000 feet and endangering his ability to get home.
Mission control was unclear if he reached the 100-kilometer mark. All of us thought we saw 328, but none of us saw anything more than that, so we knew it was close.
I watched it count up to 326, 327, 328. Dangerously close, but above, and I turned around and congratulated Paul Allen right at the moment.
Congratulations.
At the edge of a new frontier, the ecstasy of success switches in an instant to concern that Spaceship One is in trouble.
Yeah, you need to do the work northwest when you can. I see that. And Doug, run pitch trim. Mike, enable pitch trim back to about 2.5. That was a, okay. Whoa. Coming back. Whoa. Pull the breakers. Pull the breakers.
As they make final adjustments for re-entry, a malfunction puts the program in its most dangerous spot to date. The trim control on one side of the craft locks at its extreme position. Mike tries to correct the problem by changing to backup mode.
Backup stab trim. Okay, backup stab trim to center.
Spaceship One doesn't respond.
This is not good.
I thought, well, obviously the reason it's not coming back is because the tail's gone. So that only reinforced my mental picture of what might have happened during the explosion. So that didn't help me mentally at all. You know, I was very concerned that I couldn't get back at that time.
Copy.
Ground control can see that Spaceship One is intact. But without solving the problem, everyone knows that Mike is in serious trouble. In their current state, the trims would force Spaceship One into an uncontrollable and possibly inescapable downward spiral.
Best case scenario, we would have lost the airplane. Worst case, we would have lost the airplane and Mike. Yeah, it's a scary thing.
Mike, if you copy, back up stab, trim to center the roll. I'm trying. Copy.
Yeah, a little forward, farther forward, stab trim.
I knew that was, we couldn't live with that problem. I tried everything I couldn't get it to come back, and then I waited a few seconds, and then I tried again, and it did come back.
Got the roll centered. We're in the backup mode. That looks good.
Okay, let's leave the trim alone until we get down.
That trim is adequate for landing.
In his final moments of weightlessness, Mike tests space.
I did that without anyone's knowledge. I wanted to show people what zero-G feels like. You know, you can feel it, but you can't describe it to anybody. So I thought of some candies, you know, something that would be able to be squashed by the control system if it got in the way, and something that would really explain to people who've never seen zero-G exactly what it feels like and looks like.
Gravity once again takes hold of Spaceship One as the candies settle.
Okay, here comes the G's, 5 G's.
G's coming down.
Peak G's passed. Mike, you doing okay? Doing great. Copy that. You just have to work northwest when you get down. Right. Bring the feather down, Mike. Feather's coming down.
I bet it was at least 5 minutes of concern that I didn't have an airplane that I could land.
Feather's locked.
I've never lost a plane yet. I've had severe problems in planes from time to time, but I've always brought it back. So I desperately wanted to bring it back.
Alpha has visual.
The condition of Spaceship One is still unclear to Mike as he rapidly glides toward landing.
Okay, Mike, everything is green here. We suggest you stay in your current stab configuration for landing. Yeah, I copy that. I don't think I did touch the switch. We agree with that.
As Mike Melville returns from space, 2 chase planes join to guide him home. For the first time, Mike has eyes outside to review the integrity of his ship.
Okay, Chuck, I heard several very heavy bangs and lots of buffeting, so look it over close. Yeah, it looks like the tail fairing has a big buckle in the bottom of it. Gear doors look really good. No other apparent damage. That's good news, thank you.
As soon as I heard the plane looked fine and there was no apparent damage, I just felt a huge weight off my shoulders.
Now I got the runway inside. 4, 3, 2, 1. Nice job. There you go. Thanks, Chuck. Best one yet.
A perfect landing.
Oh, thank you.
Bud said we could do it, and my gosh, we did. You know, if we can do this, we can do anything.
Couldn't have been done without you, man. Burt, my man. Oh, I love you. How do you feel? Oh, I feel great. I've never felt this good. Thank you. You did a super job.
Watching the people
go crazy and so appreciative that we had brought the ship right down to them so they could take pictures of it immediately after the flight. Hey, it just doesn't get much better than that. That part of it was the most, because I didn't really know how that would go.
I am very pleased and honored to present for the very first time these FAA commercial astronaut wings to Mike Melville in recognition of this tremendous achievement. Woo!
I just think of myself as an ordinary guy who flies around the Mojave Airport for the last 26 years.
I want you to sign
Just to create a nice cup like that?
Yeah.
Suddenly here all these people are, and all of them want me to sign their stuff, and that was amazing that people suddenly would put me up on this pedestal and act like I was some kind of special person. But it meant a lot to me. It really did.
After his public celebration, the world's first astronaut comes home.
Coming home. We're gonna roll together on rocking chairs. Okay.
It was hard to believe that our program's goal all of a sudden has been reached. The thing that I set off to do, and that is to show that a little guy like me with a small team here in Mojave could fly a manned space flight, that's done. It's successful.
Yeah, good match up, man. Good job, brother. Put together a hell of an airplane, man.
I think it's going to take a day or two to actually sink in what we did, but Mike made it. He's safe. The airplane's in one piece. Oh, boy.
Memories of this day and these years hang fresh in everyone's minds. Soon they may drift from view. But perhaps the impact of these efforts will clarify with time.
Expectations of what individuals can do has been slowly degraded over time, and nowadays people think you need large multinational corporations or large governments or international cooperation between Russia and China and the United States and millions of people to do something fantastic. And hopefully we've shown today that 20 people can do something fantastic.
Since most of us were kids, most people play in the backyard and look at the stars. And they go, boy, I wonder what it's like up there. Dreaming about, man, someday I'm going to be able to go into space. Let's get people excited about space again. Let kids grow up thinking, man, I saw that Spaceship One thing. Maybe when I'm older, I can live on the moon or whatever. So I'm really hoping that people see the significance that it is, not just as a circus stunt in the middle of the desert.
Would you like an M&M that's been to space?
Anybody who goes out and tries to do manned spaceflight in the future has a different benchmark to compare themselves against. It's no longer insane to think of a private company doing a manned spaceflight. What this means, I think, is enormous to what you'll see happen the next 5 years, and more importantly, the next 10 or 15 years. So this is huge compared to anything I've ever done. There is a understanding that, hey, Rutan can do it, I can do it.
Cross your fingers and say